Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com program, brought to you by Techstrong and SUSE. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to rewatch or maybe share with a friend, the on-demand recording will be made available shortly after we conclude our live recording today. If you have any questions throughout today's program, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of the screen, where you'll find a couple of other options. The next most important one is the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you're tuning in. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's program. So our topic is zero effort, zero trust for blocking 0 days in Kubernetes. And I'm joined by Tracy Walker, Senior Solutions Engineer at SUSE. Tracy, thank you so much for joining me today. Would you like to take it from here?
Sure, Cody. Thank you very much. Hi, everyone. My name is Tracy Walker. I'm a Senior Security Engineer for SUSE NeuVector. And I'm going to be here to talk to you about zero trust and zero effort, zero trust, which if you're thinking automation, maybe, yes, that's what we would be talking about. So tell you what, let's go ahead and share my screen. And if everybody can see that screen.
We sure can.
Awesome, perfect, thank you. All right, before I begin, I just wanted to make a couple of clarifications. I'm gonna be mentioning SUSE NeuVector a lot. I'll try to use the term open zero trust, but just so you're aware, SUSE NeuVector, or SUSE, is donating or forking NeuVector to the CNCF. This is in process, so if you go to the CNCF right now, you're not going to find Open Zero Trust, but that's going to be the name for it. Open Zero Trust and the Open Zero Trust project is essentially the NeuVector code that's being donated. SUSE will continue to develop and expand NeuVector, but this gives us a way to continue to provide that to the open source community. SUSE NeuVector is 100% open source, so you can download the images from Docker Hub. You can examine all of the code on GitHub. All of our documentation is available on that link. So if you want to go to open-docs.neuvector.com, you will find our documentation for NeuVector. So everything that I'm going to talk about today, regardless if it's the Open Zero Trust project or NeuVector, it's all available for download right now. It's free to use, unsupported. There are no paywalls currently. That could change in the future, but today, everything that you see in the product, everything that I'm going to demonstrate today is free and downloadable. So if you are interested in SUSE NeuVector, try it out. Give it a try. It's a full enterprise product, and it's, again, open source and free to use, unsupported. SUSE does sell support, so you can use the software for free, unsupported, and of course, we can support you if you'd like to do that. So first thing we got to get out of the way is what is zero trust. There's lots of zero trust vernacular going on today, so I'll try to keep everything straight. Even when we talk with prospects and things like that, I keep a buzzword bingo card handy on one of my tabs. I took a quick screenshot of that because that's kind of the reality of our security world. There's lots of buzzwords that are used, and zero trust has become, it's kind of risen to the top of the heap, if you will. Everybody is using the term to describe all kinds of things, and most of those things probably are some form of zero trust. So I kind of want to clean the air or clear the air, and just kind of let's keep it simple of what zero trust really is. All right. So, and I'm not going to get into all of the governmental things. If you Google zero trust, you're going to get a long list of security vendors and government articles and various things. At a very, very simple level, zero trust just means we're going to deny all by default. We have a complete list of trusted entities, things that can be people, that can be devices, that can be network connections, right? There's all kinds of layers within an architecture, within an environment, right? When we're talking about servers and routers and firewalls and load balancers and just all of these things, how you even get into a data center is usually zero trust. And we can talk about some examples of that. There is a term, zero trust network access, ZTNA. That's, I'm sometimes annoyed when acronyms come up to try to define things that people then try to sell. I don't know that ZTNA is necessarily something different about zero trust that isn't zero trust. So I'm not going to be using that acronym. Very simply, never trust, always verify. That's just kind of the way. So again, lots of real world analogies, right? Airport security, in the US anyway. Going into an airport, when you go through security, you have to provide your ID that proves who you are. And you also have to provide the ticket showing that you're flying somewhere. That's essentially zero trust. Anybody who gets past security, you've been scanned for large metal objects, you've presented your ID, verified who you are, and verified that you actually have a ticket and you're going somewhere and that you should be allowed to go into the terminal, right? Anyone who gets into the terminal is now essentially trusted, right? To a degree, right? There are lots of doors if you go through the airport terminal that say, do not enter. If you press this bar, an alarm will sound. It's like access to the jetway or access to the actual, where all the planes are and things like that. So that's zero trust. If you get into the airport and you're past scanning and then you decide you're going to go run out onto the tarmac or the runway, you're no longer trusted. They're probably going to arrest you. And you're not even going to be able to get back into the terminal. They're going to take you into a small room and ask you lots of questions and things like that. But that's essentially zero trust, right? We don't let anybody in here by default. You have to come through some kind of security mechanism. We have a list of who those people are. When you present your ticket, we can verify that that ticket is valid, that your name on the ID is the ID that's on the ticket. You're free to go and get on your plane, right? Same thing with most environments. So that's the principles that we're going to be talking about, creating this list of what is known, and then basically preventing anything that is unknown, right? So that's kind of the concept of zero trust. You do this with RBAC all the time, role-based access control. We have a list of users. When those users come, they come in and they provide a user ID and a password. And that's maybe the level of zero trust that you have. We just have a list of all of our users and they have all passwords and we know that verifies who they are, et cetera, right? So lots of different ways you can implement zero trust in lots of different layers. What we're going to be talking about today is really kind of an application layer, a network layer, process layer. So some of the ways that applications actually run. That's what we're going to be focusing on today. Another thing I wanted to do is kind of talk a little bit about threat-based controls or signature-based controls versus zero trust. And so I have over here on the left-hand side some examples of threat-based controls. So CVE scanning, right? We're looking for vulnerabilities, and we do CVE scanning, we do CVE remediation, et cetera. That's a threat-based control. We do not have a complete list of every possible threat known to man, right? The reason why we do not have a complete list is because it is constantly being added to, right? And there are 0 days. So a 0 day means that it hasn't been published as a CVE, right? So 0 day attacks just means that we do not have a definition for what it looks like, how it attacks our environment, how it tries to infiltrate, escalate privileges, those kind of things. So threat-based controls just means you have you can have a list of CVEs, but it's never complete because there are these things called 0 days that can't be on the list. Once they get on the list, then it's a known published CVE. So that's why CVE can't be zero trust, right? We're just going to have to patch everything we can. Data loss protection. Usually this means that the network traffic is being examined for specific data that you don't want to lose. You don't want it to egress your environment. That again also is kind of signature based, right? We're looking for patterns for like credit card numbers or some kind of a personal ID or something like that. We don't want that to leave. And if we see that data leaving, please stop it, right? So that would be data loss protection. Can it prevent every possible formation of that data? Maybe not. Or, we don't know that it's a complete list. So all of these threat-based controls usually do involve some kind of list, but it's just not a complete list. We can't trust that it covers every possible thing that's out there, right? Various network attacks, right? We have a long list of known ways people can attack your network. That's a complete, that's a list of things, but it's not complete because there's still zero-day approaches that we haven't seen yet that we can't add to that list. Zero trust means that we know this list is complete, even if it's changing, right? Even if you've got different people visiting a data center day to day, if you're not on this list, you're going to have to go through some kind of long process to get your name added to that list. And we're going to have to verify and all of these kinds of things before we allow you to be, allow you to enter the data center or whatnot. Admission control, I added this one down here because admission control, and what we're talking about here specifically for Kubernetes, is the admission controller, right? The mechanism by which we can check an image for various things before the image is allowed to run inside of a cluster, right? Execute. So when we talk about admission controls, that also can even be used a little bit for zero trust. Elements of that can be used for zero trust, like I only trust this registry to pull images from, right? That essentially would be zero trust, right? It's a complete list. There are no other registries I'm going to pull images from. I'm only going to pull images from this particular registry. So that might be an example of zero trust using admission control. But most of the admission control rules are just looking for things like, does the image run as root? Is it sharing network spaces between different applications within the cluster, things like that. The examples of zero trust controls, well, we're going to cover this pretty in depth. And this even gets a little bit more specific to what NeuVector or Open Zero Trust can do. But this is kind of what we're talking about as far as the NeuVector zero trust controls. So we're able to learn automatically all of the network that's happening, all of the processes that are running inside of the cluster per container. We know any processes that run on those. We can even identify what applications or what binaries might access certain files so that we know, yes, it's okay if this application accesses this file, but anything else that tries to access it, or if somebody shells into that container and tries to, cat or look into the contents of a file or directory or something like that, we would know about it, could block that from happening. And if you have a complete list, being able to export that behavior as code so that you can have the exact same behavior, the same security across multiple environments, multiple clusters, that's something else that NeuVector can do as far as the zero trust controls. So I'm also going to spend just a touch of time, a little bit between supply chain security versus runtime. So supply chain security is essentially as you are developing an image in development, testing it in QA, retesting it in, for pen test or performance test or whatever, but anything that's trying to, deploy into a production environment, and the supply chain and the pipeline that makes that happen. So that's usually where we get a lot of CVE scanning, right? Scanning for CVEs in the pipeline, remediating CVEs, remediating that IT debt. That's a big job. Almost everyone is doing this. To the point that we even sometimes see that this is the only thing that companies are doing. Not that they intentionally are adopting, a security policy of, well, if we've patched everything, we can't be hacked. But that's essentially the security policy that you're implementing if you're only doing CVE scanning and remediation in your supply chain, in your pipelines, things like that. You can see the bullets here. You have to have a CVE signature to identify it, right? You have to have something that says, well, this is what it looks like in these libraries or whatnot. and once you can identify. So you have to have it published. Usually that means you also have to fix it, patch it, update something. It will not protect you against a 0-day. So that's the fallacy of, well, if I've patched everything, I can't be hacked. That's not true. If you've patched everything, that's good. That's awesome. You still need to be able to monitor your environment to see if something is happening that you're not aware of, or something that hasn't been seen, or some kind of exploit that hasn't been published or discovered yet, right? Like a 0-day. So again, no protection against 0 days. Inconsistent results vary. What I'm talking about here is that you can have 5 different scanners scanning for CVEs of your images, and you're probably going to get 5 different results. Scanners work differently. Different companies have developed scanners and how to identify and match up what the CVE says versus what's actually in the environment. And we work with the U.S. Department of Defense, Iron Bank. The Iron Bank, when it's checking images, uses 3 different scanners to check, and then they compare the results against those scanners. When we talk with prospective customers and they already have, maybe they're using an open source scanner, our recommendation is don't rip and replace that. Keep using that scanner. NeuVector has a scanner in it also, can scan for various CVEs from 17 different sources. But again, results can be inconsistent. I like to compare results of scanners. I personally, and when I was running, responsible for security in various environments, I would not trust any scanner. I never trusted the results. I would always wanted to see that we were clean, but I never trusted that we were absolutely clean, as far as having no CVEs, because you can always experience a 0-day or something that the scanners cannot detect. Obviously, no visibility into anything that's actually running, right? Scanning for CVEs usually happens within a pipeline. NeuVector can scan images for CVEs that are running live in the environment, but doesn't make any difference if you find a CVE or not. It doesn't tell you if it's actually being exploited or not, or if someone is taking advantage of that to hack your environment. And a real quick comment about source code analyzers, or SCA or SCA. Source code analyzers, it's a worthy security layer. In my personal experience, you don't get a ton of value. You do get a ton of work out of it, but sometimes you don't get a ton of value out of it because source code analyzers have a difficult time really kind of connecting the dots, right? They might find an exploit or a way to get in. That would be like a source of, that allows me to get into an environment. Doesn't really correlate with then what can I do once I'm in, right? Which is like the different sinks, sources and sinks. How do I get in? And then what can I do once I get in there? Just evaluating the code and trying to match all of these things up without the actual application actually running. Maybe it's providing some benefit, but I'm keenly aware that it doesn't really give you a full picture. It can find some things, it can help you format your code much prettier and things like that. But it's a good security layer if you can use it. I wouldn't spend a ton of time if you can implement something that's doing more runtime. Now, the behavior-based zero trust runtime on the right here, this is specific to NeuVector. Obviously, we don't need any CVEs or remediation. Can block against 0 days. So when we talk about runtime protection that can block any 0 day that we haven't seen before, how would it do that? We need something to helps us understand what is a normal behavior versus what's an anomalous or abnormal behavior. Full visibility of processes, file access, network behavior via trusted sources of truth. Sources of truth is kind of an important concept to understand. When we talk about sources of truth, if we're talking about like security products like, say, Aqua, Sysdig, Snyk, StackRox, Lacework, there's a ton of security vendors out there that are using kernel filtering, kernel shims, eBPF, extended Berkeley packet filtering. This is a very, very cool technology that allows you to collect a lot of information at the kernel of the worker node. So assuming everybody kind of understands what a Kubernetes stack looks like, you have nodes, which are the VMs, the servers, and those are all clustered together running these applications and and containers and namespaces across all of those nodes. So being able to see all of the processes at the node level, eBPF allows them to filter out every process that's running on all of those nodes. Not all of the processes that run on the nodes are necessarily related to the Kubernetes cluster, right? There's other things running on those nodes. So that's why we say they have to kind of filter out things that are specific to the runtime environment. The one thing that they don't see, and we'll talk a little bit about this, is actual network traffic, right? They might see network processes. There's a virtual network interface within each one of those nodes that handles network traffic, just like any other server, right? We offload the actual network traffic to the virtual network interface because we want the processor, the CPU, to be running things responsible for the rest of the computer, all the processes, all the VMs, all the containers, right? So we want that to be focused on processes and routing for the network traffic, right? Usually we are not running network packets on the kernel, right? We may be doing some routing there, layer 3, layer 4. There is a way to force packets to go over the CPU, but that's not something you're going to do in a normal production environment. All right, let's last perspective, and this is an analogy that I use to kind of help, especially we talk to a lot of prospects that are very, very focused on CVE remediation, right? They want to fix all of the exploits in their environment. And no argument there. You definitely want to be doing that, right? But the analogy that I like to use is that CVE remediation is a little bit like the rearview mirror in your car. So say, for example, you go to a car rental lot and you rent a car and you get in that car and you're about to pull off the lot and go through the little gate and everything. And you realize that it doesn't have a rear view mirror, right? There's a little sticky spot where that mirror used to be. That's CVE remediation, right? That's vulnerability scanning, right? If you didn't see, you should have that mirror, right? You would go back into the office and complain, hey, the mirror is missing. I need that mirror. It's a safety device, right? I need it while I'm driving. And they'll give you a different car, or maybe they'll fix the mirror, right? So it's the same thing as vulnerability scanning. It's a historical perspective. You can only know about the CVEs that have been identified today or yesterday or last week or last year, right? It's always in the past. You do not know what CVEs are coming out tomorrow or a week from today or a month from today, right? All of that stuff that's happening in the future, that's your windshield, right? So if you can't see CVEs into the future, you need something else to be able to tell you when something is happening in your environment. You need to be able to understand your network traffic, your processes, the behavior of your application, so that if something is amiss, if there's a pothole, you can avoid it, right? We're always going to be fixing CVEs, and you should. So this is not saying, that's a terrible security layer. No, it's a security layer. And as all security layers, defense in depth, no security layer should ever be assumed as perfect. That's why we have multiple layers, right? These layers help each other. If you remove CVEs and exploits, it makes the environment safer to make sure that nothing else is happening. But if that's the only thing you're doing, then you really don't know what is happening. You only know that you have prevented exploits that you know about. You can't predict what a 0-day is going to do, the behavior that's intrinsic to that. So that is why the runtime security is so important and is such an important security layer. All right, a couple of just a really quick questions. I'm not doing a poll here, but if you start to think about what's the best way to manage CVE patching on one cluster or 100 or 1,000, right? Because it's really the same process, right? You're trying to remediate these exploits and patch things and update things so that they contain, have removed these exploits. What's the best way to manage CVE patching on between 1 or 1,000? I don't know. I think it's the same though. Regardless if it's 1 or 100 or 1,000, I would like to remediate those CVEs in exactly the same way so that the scale of my environments is not impacting me. That's sometimes very challenging, but also very difficult, right? We're going to have to rely on some kind of automation to do this, to manage CVE patching. This is a big challenge for a lot of companies, and they struggle with this at times. This can delay releases. This can slow down their velocity, which is key, right? We want high velocity. We want to develop and deploy software as fast as possible. So I don't have a good answer for this other than use some runtime security so that you can take the pressure off of trying to manage CVE patching, especially in large, complex environments. Another question, and we do get asked this, what is the best strategy to patch CVEs on 100 clusters or 1,000 clusters? What's the best strategy to do this? Various recommendations you might get. Use your best effort. Admission control rules, right? That's admission control, checking the image. Can we actually do that? I'm not sure. Mob boss mentality. It's come up before, and I kind of kept it from something somebody said, but the mob boss mentality is, hey, you should fix those CVEs. Be a shame if something happened to your release date if you don't pass that CVE, right? It'd be a shame, right? So operations, the security teams putting pressure on development to patch CVEs, and and if you don't do it, something else bad might happen. That's one way to get across. Runtime security. Can we add runtime layers of security to block those? The answer to this question is actually all of the above. Every one of these things can be used to contribute to patching CVEs. You can use admission control rules to say, if this image has CVEs, don't let it run in my cluster, right? So actually all of these things. Now the mob boss mentality, be ashamed if something happened. There's friendlier ways of influencing your development teams to patch things. And one of the better ways of doing that is actually give them more time to do it. Have security layers that can prevent 0 days or unpatched CVEs. Because if you don't have to patch them, or you need time to, eliminate some of the debt attached to those CVEs, that can save you a lot of time. All right, so now let's talk about NeuVector and how NeuVector does 0 day and how we can do this with zero effort. So I'm going to explain a little bit of this, and then I'm going to show it to you in the NeuVector UI. The thing that NeuVector is doing is it's actually inspecting network traffic inside of the cluster. And it's doing this independently of Kubernetes. We're not using Kubernetes IP table changes. We're not really using all of the settings in Kubernetes. You could have network security policies set in Kubernetes saying that this traffic from this container should go to this container and this pod over here. So you can have rules that define where things are supposed to go. But the weakness in some of those rules is that even though you're defining where it should go, it doesn't necessarily mean that you're denying traffic anywhere else. You've defined a route. We would like you to take that route. But somehow, if the car doesn't make it to that route, you may not know it. Another analogy, this is a little bit like knowing a car is supposed to go from point A to point B. You have a route. You don't know what the car looks like. You don't know what's in the car. You don't know if it's containing anything in the trunk. You don't know who's driving it. And you don't even know if it reached its destination. All you know is it was supposed to go from point A to point B, right? NeuVector solves this. Now, you may see some of that information outside of the cluster. You may be able to tap traffic or inspect network traffic going into a cluster. But once it's inside of that cluster, especially if you have any services that are exposed to the open internet, mercy, yeah, you really need to know what's going on inside the cluster real time. And that's exactly what NeuVector Open Zero Trust does, is able to inspect the actual network traffic. And this is the network traffic that comes off the virtual network interface, right? We don't have to ping the kernel. We do not have to use eBPF. We don't have to use multiple sources of truth. So some products will watch all of the IP table changes happening inside of the cluster. NeuVector doesn't have to do that. In fact, the source of truth for NeuVector is the actual network traffic itself, right? Coming off the VNIC on those nodes and seeing all of that traffic independent of what Kubernetes is reporting. So that's, even from a security standpoint, even better, because it's independent source of truth for that network information. Layer 7 protocol. So NeuVector is able to decode the network traffic and identify the protocol that it's using, layer 7 protocol, and then even validate that protocol. I think, I usually have multiple screens, but I think we identify 35 different application protocols. And in those protocols or in that network traffic, we can also identify about 23, 25 different types of network threats. And NeuVector is also able to identify all the processes happening on all of the containers. And again, not using kernel filtering. Kernel filtering eBPF is great at identifying processes that are running on the kernel. Fantastic at doing that. But doesn't really do much blocking of those processes. So enforcement of security policies, especially network security policies, really can't do that with eBPF because it really doesn't see the network traffic, doesn't really have a basis for why it would block based on that. So no blocking with eBPF, and even if it's doing some blocking of processes, that means that the process had to reach the kernel. If there was a way that we could stop things before they got to the kernel, that would actually be better, because then we're not relying on this kind of last effort at the kernel to try to stop something that happened there. It'd be nice to stop things in the network layers before something reaches the kernel. And that's also what NeuVector does. It's using the behavior of the network traffic and of all the processes to essentially build that zero trust list. We have a complete list of every network connection these containers make. We have a complete list of all the processes that these containers are using to run in the service. And therefore, anything that is not that behavior, that becomes anomalous, that becomes suspect, right? That's what the zero trust is doing. We know ourselves, therefore anything that is not us has to become suspect, right? And that's what we want to investigate. So therefore, if you want to think about it, the signature that we're using here is our own application behavior at a network and process level. Let's continue. So because NeuVector can use an independent source of truth for the network definitions to create this zero trust behavior, list of policies, it does all of this automatically. It can identify that behavior automatically. It can automatically generate those security policies. You can even automatically export those policies as security as code within your SDLC, within your pipelines. You can export that security policy and apply it to other clusters. So they also enjoy the exact same zero trust segmentation. This is why you can block 0 days. There is no 0 day, there is no exploit, there is not even a known CVE that is going to match the behavior of your application, right? The processes and network connections that your applications, your services are making are unique to your applications. And so therefore, anything that is not your application behavior has to be suspect, right? And that goes for 0 days, that goes for unpatched CVEs. I have a slide and a demo that we're going to explore this and prove this point out for us. NeuVector can also do some things like packet capture. When we see a threat in that network traffic, we can do the packet capture. That is not zero trust, right? Having a list of all these network exploits is not zero trust. It's another security layer. If we identify something that we could recognize, sure, we should block it on that basis. But that's not the zero trust. Same with the data loss prevention, the DLP and the WAF functions. These are based on regex pattern matching. So again, not really zero trust, just doing some pattern matching to do DLP and WAF and doing it inside of the cluster. These are the layer 7 protocols that we were talking about. So again, we validate these protocols with NeuVector, Open Zero Trust. And when we do that, we are automatically looking for this list of threats. Again, not zero trust here. This is just another security layer saying, if I'm able to match on these threats, we can block based on that, right? So we can go even further. All right, so the demo that I'm going to do is, or show you here, is what we're going to do is we're going to take a demo that if you've ever seen me do a demo before, you'll know what this is going to look like. We're going to take a single container that's running a web application. It's exposed to the open internet. And we're going to see the behaviors. We're going to look at the processes and the network behaviors, and we're going to delete them. We're going to start from fresh. We're going to move that container into what we call our discover mode. The discover mode is going to learn all of the processes and all the network connections that are happening within that container. Then I'm going to change that mode to protect mode. Now this is saying a monitor, right? The monitor mode and the protect mode are the two operational modes, right? These are the modes that you're going to be using when you're securing the environment. The monitor mode, as you might expect, just means we're going to alert, but we will not block anything. We're not going to enforce these policies from a blocking perspective, but we are enforcing them from a, hey, what was that? We're going to alert you to anything that is anomalous to your application behavior. So this becomes a very safe way to kind of test to make sure that, yeah, the behavior that we defined is accurate and you shouldn't be getting a ton of alerts on anomalous activity. The protect mode, and that's where we'll start, we'll back into the monitor mode, but the protect mode is full blocking. Any anomalous activity at a network or process level, NeuVector can block that behavior based on the fact that it is not your application behavior. That's zero trust segmentation. So that's the little demo that we're going to do. And then we'll go back over how that zero trust can block 0 days, but we're actually going to demonstrate this just a little bit. So let me here we go, find my location here. And so what we're looking at here is NeuVector. Now I'm going to need to bring up a terminal. So give me 1 second. And what this is basically going to show us is it's going to show us that we've got our NeuVector deployment. So we have some controllers, the enforcers here. We have 1 enforcer per worker node. So this is a 4-node cluster. And you can see all the services that we're running here. And so what I'm going to do is let's go to our policy groups in NeuVector. And if I scroll all the way down to this one container, this struts, Vader struts, I've got it in a Vader struts namespace. Down here, you can see, we're going to examine the processes that we've seen. So we have seen Bash, Java, and Pause. So Pause is a Kubernetes process. Java is what this container is running. In fact, this container is running Apache Tomcat. So this is the container, and this is the service that it is exposing. So this is kind of a simple demo app. It's just a website. We can add things and do, make it run. So that's what NeuVector sees of this container. So we're going to delete these 3 behaviors. So we're not going to have any. Now notice also it's in a monitor mode, that Vader struts container. So again, monitor means that we don't block anything. We're going to alert on it. And since we don't have any process rules, now any process that runs is going to trigger an alert. We're going to fix that here in just a moment. Network rules. So you can see here, we've got some HTTP, DNS. I've got a rule here for deny any network connectivity to Google API, something for another demo. But what we're going to do is go to the network rules here. And this is like a little bit like a firewall, right? This is an ordered list. You can see all the allow rules, right? Because this is zero trust based. So we start deny all, and then we allow things that we have seen or known. So let's just filter down. I'm going to delete these network rules. All right, I'm just leaving my user created because I like to use that for other demos. So now we are going back to policy groups at the very bottom. And like a good magician, doing a magic trick, although this is not magic, no processes up my sleeve here, no network rules except for the one that I have created. We're not actually going to, we can ignore that for a moment. File access rules. So the file access rules work a little bit different. You have to add a mount point or a directory or a file location, and then we can monitor anything that accesses that file. You'll notice here, allowed application. So in the discover mode, we'll even learn if an application is accessing that file, and we will allow list it based on that. And that way, when we start enforcing anything else that's trying to access that file, it gives us an opportunity to say no. If you're thinking about, well, what about all of the system locations like Etsy password? I don't see that one there. That's one of our predefined filter. Etsy host, user local bin, Etsy password, Etsy shadow, all of the system or the sensitive system locations within the container, we are already protecting those by default. So you don't have to add anything for just the system file protection. So like I mentioned, we are now going to move this container to a discover mode. So we're going to learn its behavior. All right, it's in discover mode. All I need to do to learn the behavior is exercise the application a little bit. All I'm going to do here is just refresh the page. Let's create a new order. Create that order there, and let's delete Jim. I'm just going to delete one of these. If you're counting, I've executed 3 HTTP requests. I refreshed the page, I added one, I deleted one. If we go back to NeuVector, because we're learning this real time, and I hit this refresh, watch down here at the processes, watch what we see show up. Well, there it is. Java is running, and pause, because pause is a Kubernetes process. There's HTTP traffic for the network rules, right? We've already relearned this automatically. Let's make it just a little bit more interesting. I'm going to shell into that container. Let's clear my screen. First thing I'm going to do here, and I'm going to make this just a touch bigger so that you can kind of maybe see the commands I'm running. I'm going to run a who am I? I am running as root inside this container. That, for most environments, is already a security violation because that means I can do just about anything that I want to do. If I do an ls, let's do a remove of index.html, and let's recreate it. wget, let's just go google.com. I can make network connections out. I can run processes, all of these kind of things. What is NeuVector saying about all this? Well, if I hit refresh and go to my process profile rules here, you'll see there's a bash and the clear and the du and the ls and the remove and the wget, right? All of those processes NeuVector just learned. If I go back to my network rules, remember that wget to Google, yeah, there it is, DNS, right? We saw some DNS traffic to pick up that, to do that wget of Google's web page. So now I'm going to move this to a protect mode, right? And change our mode to protect, which means that we're going to enforce that nothing else happens in this environment. Although we just did the bash, so I'm going to delete bash and the clear and the du, the ls, the remove, and the wget. We're going to delete those because I know, oh, that was just me kind of messing around right there, right? Java and pause are my real processes there. I'm not going to worry about the network settings. I'm still in that container. Who am I? Operation not permitted, but I'm root. ls, du. How about, we removed a file. How about a remove, and let's just do a recursive force of every file on the container. Not permitted. That is zero trust. If it's not running Java or pause, we're not going to allow it. That's what that means. We're using our application behavior to define what is zero, what is allowed versus what's not. I don't need a CVE to tell me that these things are no good. If I exit this container and I try to get right back into it, I cannot get back into that container, right? I just tried that twice. That's because we've got the zero trust. If I go to my security notifications, at the top here, you will see there's that bash that I just did, right? You're seeing us deny all of these rules. In fact, remember that Google rule, that network? That's the network rule, that manual network rule that I added, saying anything that hits star.google.star, let me know about it. And so that's exactly what that was. If I wanted to allow bash, I could allow it right here from my notifications. Maybe there's a process we need it to have, even though we haven't actually exercised it. That would allow me to go back into that container as root. Who am I? Not permitted. ls du. I still can't do any of those things. What if I attacked that container? So let's do an attack. This is a script. It's a Python script. Basically, what it's going to do is it's going to inject into my HTTP request a netcat. So you can see it down here, that NC to there's the IP address that I'm going to route my reverse shell to. So I'm going to try to establish a reverse shell so that I can run commands on that container. I'm going to do that on the 1337 port, and there's the shell. So I hit return. Notice that it's just kind of sitting there, not doing anything. If I come back to NeuVector and hit refresh, and the demo gods are still kind to me, there we go. Apache struts remote code execution. So this is an RCE, trying or attempting to execute something in this environment. We denied it, and we're not going to allow that to happen. I'm refreshing my session here. And also, you'll notice this show packet, because we did an automatic packet capture when we saw that threat. If I scroll down, you can see right there, there's the NC, there's the IP address on the 1337 port, right? That's a packet capture of that actual attack. Another proof point that NeuVector is looking at the actual network traffic. What if this container was not in a protect mode? What if it was actually in a monitor mode where we don't block these things? So I've now changed that to monitor mode. Let's run that attack again. It just timed out. I'll clear my screen, run the attack again. Now see, that time it came back right away, right? I did get an HTTP status 500 from that web server. So I know I'm talking to that web server. What did NeuVector say about this? Well, we see again the Apache struts remote code execution, right? But notice over here on the right-hand side, see, before we were getting denies, but now we're getting alerts. And the two that you didn't see before, right? A minute ago, when we blocked this, we only blocked it based on just the network thread alone, right? You didn't see anything else happening there. But this time, now you're seeing there's a shell, there's a netcat, that NC, these processes were attempted this time. Why? Because we weren't blocking anything. We're basically seeing the entire kill chain right here. In fact, if this was a 0 day, you could ignore this right here, right? Because again, our threat detection is not zero trust. It is signature based, it's threat based. We have to have a list of all these threats. It's not a complete list. So if it's a 0 day, you're not going to get this alert right here because we're not going to know what that looked like. That's why it's called a 0 day. We don't know. But we do see the netcat, we do see the shell, and there's one more I need to see here, and there it is. That's the egress, right? We were coming in through a known HTTP rule. I had a rule that says that HTTP traffic was allowed, but inside that traffic, we had the netcat, the shell, and then the egress, that also was new to NeuVector. It was anomalous. So this is now what we want to look at here, right? What you're seeing there, that protect mode blocked that attack and nothing else was able to be seen. But in monitor mode, we saw the shell, we saw the netcat, we can ignore that Apache struts, and there's that implicit, that third layer, right? Multiple opportunities to stop this attack, either at a process or network level, right? That's what zero trust does, right? We can block at the first, even if we don't know the threat, but we can block at the first instance that we see anomalous behavior. And again, we've done this all on this call, right? We've defined those rules automatically. We have now enforced those rules automatically. And like I mentioned, if you're doing this in an SDLC, if you're doing this in a lower level environment, like a development integration test or a QA environment, You can do the learning. You can have the rules built automatically. You can even export those rules automatically. Let's call that one Tracy. Let's open that file. Security as code. And there it is. So this YAML file that we have built automatically contains all of the security. In fact, we've even got, like, there you see DLP, egress, we have file protection. So there's the file protection we were talking about. The processes, remember we added that bash back in there. So that's why that bash is in there. We added it back to our rule set. Otherwise it's just Java and pause, right? It's in a monitor mode. We have WAF settings, etc. So this is your zero trust security policy. And we recreated this entire thing automatically on this little webinar, right? That's how you can do zero trust that blocks 0 days with basically zero effort. I guess it's maybe not a complete zero effort, but very, very minimal effort to deploy and run this. Again, fully open source. You can download NeuVector, deploy it into a cluster. Everything will be in a discover mode automatically. So it'll immediately be learning the behaviors of your environment. It'll even scan the environment, right? We are scanning for CVEs. We can see CVEs in the platform, the nodes, right? We see compliance settings, we see vulnerabilities and the containers. Yep, we can see the compliance and the vulnerabilities in the runtime environment. But when you have that runtime protection, you can now buy time to remediate those CVEs. We've even had customers using the admission control rules that we implement. You can see here, no more high severity CVEs with a fix reported 45 days ago. This is for the teams that are building those CRD files. If they're building runtime zero trust policies, now security can say, you've got more time to remediate those CVEs. For those development groups who are not playing ball with security or operations and not creating these files, this gives them another way of saying, well, you're still going to have to ride that treadmill of CVE remediation, right? And we need you to respond to that within 3 days or 5 days, right? Very, very quickly. Whereas if you're using the runtime, the zero trust, that gives you more time because you have provable ways of blocking a 0 day or unpatched CVE, and that gives you better runtime security. That is the end of our program. Any questions?
Hey, Tracy, it looks like we've gotten a couple, so let's go ahead and just take them from the top. So starting with this most recent question, what source are you leveraging to look for CVEs?
What source are we leveraging to look for CVEs? NeuVector is using the sources. I think that I'll take, let's see, CVE. If I search for our CVE database sources and version, you can see here are all of our CVE sources. So you can see here NIST, SUSE Linux, Ubuntu. I think we have 17 different sources. Microsoft Mariner was the last one that was in our latest 5.0 release. And so those are our sources.
Thank you, Tracy. This next question reads, I want to work on container security. How can I work on this? Is there any access for students?
Absolutely. Go to the, let's see, jump back. I don't know where that slide was. I would say absolutely go to these sources right here. Go to Docker Hub, search for NeuVector. You'll see the NeuVector images there. Now, you don't not have to pull them from there. What I would recommend is go to the documentation. So you see the documentation link right there. Start there. When you go to our documentation, so let me just go to the top of our documentation at opendocs.neuvector.com. If you scroll down just a touch, deploy on Kubernetes, deploy using Helm charts, using OpenShift operators. NeuVector works in any cluster, any cloud, just about any CNI. We're CNI agnostic, we're cloud agnostic. As long as you're running a flavor of Kubernetes or even just Docker. We can even do this kind of security with just Docker. But if you're deploying your student, set up a small cluster, and here are all of the details of how to deploy. Gives you all of those instructions step by step. That's how I would stop, and then do some YouTube searches and find some other videos and where we're doing some highlighting different capabilities.
So does NeuVector support service mesh topology?
Yes, it does. NeuVector, let me find the slide, supports Istio and Linkerd. Yes, so here, great question. Oh, geez, let's skip through all those. It's a hidden slide. Is that what this is? Find it here again. There we go. All right. Service meshes are using usually a sidecar architecture. What that means is you can see down here this Istio proxy. So for every container running, they create a sidecar. That sidecar is kind of like, that's my twin brother. And all the network traffic is supposed to flow through that sidecar. So if you're going to do encryption within your service mesh, you are encrypting between all of the sidecars. The thing that is really, really important to understand is you're only encrypting between the sidecars. You do not encrypt this connection between the sidecar and the container, its container proxy or the container and its proxy. So this connection right here is not encrypted. NeuVector works with all of this. So there's the loopback. That just means we know that there's a sidecar. We're still able to learn, even if it's encrypted traffic. We don't decrypt the traffic. We just identify it as encrypted traffic, and we build a rule for that traffic. If we see traffic that is not SSH or SSL, I should say, that's anomalous. Why wasn't that encrypted? So now we have a way to say, yeah, that traffic, if it's not encrypted, we're not going to, we're not supposed to allow it. We're going to alert you to it or block it. We can still do packet capture of unencrypted traffic. We can do quarantine of the container and its sidecar. And this is the last one right here. So we actually have a patent that protects our ability to see and inspect that traffic between the container and its sidecar proxy. So yes, we work very well with service meshes. And as another thing to kind of look up, let's open up a new tab here. You might want to take a look at the Istio documentation. There's a section where they talk about in their traffic management egress gateway section, and you can probably highlight or I'll Control C that in case we want to paste it in the chat. But they're actually saying Istio cannot securely enforce that all traffic flows through the egress gateway. What they're talking about here is this traffic right here, that egress or that traffic between the sidecar and its container. They cannot guarantee that all traffic must use that. They can't do any enforcement until they get to the sidecars, right? That sidecar traffic, that's where they control the traffic. So this traffic, they can't secure and protect. And that's exactly why they're having under this section, apply Kubernetes network security policies, right? You're going to have some kind of security making sure that that traffic is being enforced. Well, NeuVector, as you just saw, can do that automatically. We can build those rules and you don't have to create YAML or do these extra steps. Just use NeuVector or Open Zero Trust, and we can enforce that right there.
All right, Tracy, it looks like we've got time for one final question. So what external identity access management do you support? Or is it just making an API call as long as there is an API support on the other end?
Great question. We support a variety. Let's go to settings. Here you see right here, LDAP, SAML, OpenID. So yes, we do have full RBAC control. There is also a full API, which you can download. You can load it up into Swagger Hub. So this is our 5.0 API. So everything is covered via API, but as far as actually role authentication, et cetera, we support all of these, and we do have full RBAC. So we do support various RBAC roles for scanning, registry scanning, admission control, vulnerabilities, all of these events. So we do have full RBAC and security built into the security platform.
All right. Well, Tracy, I'm going to give you the floor one final time. If you have anything you'd like to leave our audience with before I close us out.
The only thing I would leave anybody with is that just remember, security is always layers. No layer is perfect. You want lots of security layers that are working together to enhance your environment security, but that are not slowing you down, aren't impacting your velocity, things like that. So doing real runtime security like we just demonstrated here, that doesn't slow you down, that can be fully automated. It's definitely something worth taking a deeper look at if you're not already. And as far as I'm aware, NeuVector is the only product, the only security product that can do this type of runtime, behavior-based, zero trust enforcement. Lots of products out there do a lot of alerting, but NeuVector can both alert and enforce, and that becomes pretty critical. Obviously, this little presentation can't cover all of the things you can do with NeuVector or Open Zero Trust, but it's free to use unsupported. You can download it and improve your security posture within your Kubernetes environments quite easily.
Awesome, Tracy. Thank you so much for that. I tend to agree with the Swiss cheese approach as well. Many layers that work together are going to be better than one. So that's exactly right. Well, Tracy, thank you so much. To our audience, just a reminder that today's session was recorded. So following today's program, you'll get an email with a link to access today's program on demand, or you can find it living on the Security Boulevard website at securityboulevard.com/webinars, and then just be sure to look in the on-demand section. So I did promise 4 $25 Amazon gift cards at the top of the hour. So our 4 winners are Cody M, Swati T, Jacob W, and Gibran S. To our 4 winners, congratulations. Keep an eye on your email inbox to claim that gift card, but if you don't happen to see that email, do check your spam folder. I'd like to thank SUSE for sponsoring today's program, and to our audience, thank you so much for joining us for these past 60 minutes. We really do appreciate and honor your time, and we do just want to ask for one extra moment for a post-webinar survey that will pop up on your screen as soon as we close out. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and Tracy, thank you once again.
Thank you, Cody. Appreciate it.